Welcome to Astronomy Daily, your source for the latest space and astronomy news. I'm Anna, and today we've got a fascinating lineup of stories covering everything from European space developments to lunar discoveries and the mysteries of black holes. In today's episode, we'll explore major developments in Europe's space industry, dive into a groundbreaking new constellation resource, examine surprising findings from China's Chang'e 6 moon mission, look at a possible solution to a long-standing black hole paradox, and discuss an intriguing proposal for satellite defense in space. So let's get underway. The European space industry has been making remarkable progress this year, with several key developments reshaping the continent's launch capabilities. Ariane Space kicked off 2024 with a milestone achievement, the successful maiden launch of their Ariane 6 rocket from French Guiana in July. This marks a crucial transition as Ariane 6 takes over from its predecessor, the Ariane 5, as Europe's primary heavy-lift vehicle. The Vega program has also seen significant advancement. After nearly 2 years of standing down, the Vega C rocket made a triumphant return to flight, successfully deploying the Sentinel-1C Earth observation satellite. This success has led to ambitious expansion plans, with ESA signing new contracts with Avio to increase Vega C's flight frequency and accelerate development of its successor, the Vega E. Several emerging players are bringing fresh innovation to the European space sector. German company High Empulse is pioneering hybrid rocket technology, using an environmentally friendly combination of paraffin-based fuel and liquid oxygen. Their successful launch of the SR-75 sounding rocket earlier this year has paved the way for their orbital launcher development. Meanwhile, UK-based Orbex has made strategic moves by announcing plans to relocate their launch operations to Saxavord Spaceport in Shetland, streamlining their path to achieving first flight of their Proxima rocket in 2025. This reorganization allows them to focus resources on developing their innovative medium-class launcher. The industry is seeing a clear trend toward reusability, with Spanish company PLD Space leading the charge. Following their successful Miura-1 test flight, they've unveiled plans for a partially reusable Miura 5 rocket and announced an ambitious new family of launchers called Miura Next, setting the stage for Europe's entry into the reusable rocket market. Next up, a gift for you this holiday season. For stargazers and astronomers alike, an exciting new resource has just been unveiled through a collaboration between NSF's NOAR Lab and the European Space Agency. This comprehensive digital collection brings together stunning high-resolution images of all 88 officially recognized constellations that fill our night sky. At the heart of this collection are spectacular photographs captured by German astrophotographer Eckhard Slawik. Using an innovative technique that combines filtered and unfiltered exposures, these images beautifully showcase the natural colors of the stars while maintaining remarkable clarity and detail. The entire collection has been seamlessly stitched together into an interactive all-sky map that allows users to explore the celestial sphere in unprecedented detail. What makes this resource particularly valuable is its educational depth. Each constellation entry comes with extensive background information, including its historical origins and mythology. Traditional stick figure patterns are provided alongside practical finder charts to help observers locate these star patterns in the night sky. The collection also features detailed information about prominent deep sky objects within each constellation's boundaries. This project addresses a common challenge for astronomers, the fact that no single location on Earth can view all 88 constellations. For instance, observers at mid-northern latitudes miss out on roughly 14 complete constellations and get only partial views of another 15 throughout the year. This digital resource finally brings the entire celestial sphere within reach of anyone with an internet connection. The timing of this release is particularly significant as it comes exactly 100 years after the International Astronomical Union first standardized the 88 constellations we recognize today. This modern digital atlas serves as a fitting tribute to that historic achievement while making these celestial patterns accessible to a new generation of skywatchers. If you'd like to check it out, I'll leave a link in the show notes for you. Remarkable findings from China's Chang'e 6 lunar mission are reshaping our understanding of the moon's magnetic history. Scientists analyzing basalt samples from the moon's far side have discovered evidence of an unexpected surge in lunar magnetic field strength approximately 2.8 billion years ago. This discovery is particularly significant because it challenges our previous assumptions about the moon's magnetic evolution. The samples, which represent the first ever paleomagnetic data from the lunar far side, show magnetic field strengths ranging from 5 to 21 microteslas during this period. To put this in perspective, that's substantially stronger than what scientists previously believed possible at this point in lunar history. What makes this finding so intriguing is its timing. Prior to this discovery, researchers thought the moon's magnetic dynamo had entered a quiet phase around 3.1 billion years ago. Instead, these samples reveal that the moon's interior remained remarkably active and dynamic well into its middle years. The research team, led by Professor Rixiang Zhu at the Chinese Academy of Sciences, suggests this magnetic resurgence might have been driven by several mechanisms. One possibility involves a basal magma ocean at the moon's core mantle boundary. Another theory points to precessional forces, while core crystallization processes might have also played a role. These findings don't just tell us about the moon's magnetic field, they provide crucial insights into the thermal and geological evolution of our celestial neighbor. The data suggests that the moon's deep interior remained hot and geologically active far longer than previously thought, forcing us to reconsider our models of lunar evolution. This breakthrough also highlights the importance of sampling different regions of the moon. Until now, our understanding has been based primarily on samples from the near side. These far-side samples are giving us a more complete picture of the moon's complex history and demonstrating that our satellite's evolution was far more dynamic than we once believed. A fascinating new study may have uncovered a solution to one of the most perplexing problems in modern physics, the black hole information paradox that even stumped the brilliant Stephen Hawking. This paradox emerges from the apparent contradiction between quantum mechanics and our understanding of black holes. Back in 1976, Hawking made the groundbreaking discovery that black holes aren't completely black. They actually emit tiny amounts of radiation. Over extremely long periods, this radiation can cause black holes to eventually evaporate and disappear. But this creates a major problem. What happens to all the information about the matter that fell into the black hole? According to quantum mechanics, this information can't simply vanish. Now, researchers at Caltech have proposed an intriguing solution involving quantum connections between a black hole's interior and exterior. They suggest that through a phenomenon called nonviolent non-locality, the inside of a black hole maintains subtle quantum links with the space around it, similar to what Einstein famously called spooky action at a distance. These quantum connections would create tiny ripples in the fabric of space-time surrounding the black hole. While these perturbations would be incredibly small, they wouldn't be random. Instead, they would carry encoded information about everything inside the black hole. This means that when a black hole finally evaporates, all that information would still exist in the surrounding space-time fabric. The exciting part is that we might actually be able to detect evidence of this effect. The research team predicts these quantum correlations would leave distinct signatures in gravitational waves produced when black holes merge. While our current detectors aren't quite sensitive enough to pick up these subtle signals, the next generation of gravitational wave observatories could potentially spot them. If confirmed, this would not only resolve the information paradox, but also demonstrate a deep connection between gravity and quantum mechanics. Two fundamental theories that we've struggled to reconcile for nearly a century. The researchers are now working on more detailed models to predict exactly what these gravitational wave signatures should look like. In an intriguing development for space security, United Launch Alliance is looking to expand the capabilities of their Vulcan Centaur rocket beyond just launch operations. CEO Tory Bruno recently unveiled plans to upgrade the rocket's upper stage, known as Centaur, into a rapid response space defense system. The proposed enhancement would transform Centaur into what Bruno calls a space interceptor, capable of quickly responding to threats against U.S. Space Force satellites. This comes at a crucial time when military assets in space face increasing vulnerabilities, yet currently lack robust defensive capabilities. The upgraded Centaur would be equipped with powerful thrusters and substantial energy reserves, allowing it to intercept potential threats within hours, rather than the days or weeks current satellite systems require. Bruno envisions these interceptors as destroyers, or greyhounds of space, providing rapid protective response for critical space infrastructure. A key consideration in this defensive system is the need to neutralize threats without creating dangerous debris fields. Space debris can persist for weeks in low orbit and centuries in higher orbits, posing risks to all spacecraft regardless of nationality. As Bruno notes, space is a shared environment without borders, making debris management crucial. The timing of this proposal aligns with the U.S. Space Force's evolving role as a cornerstone of national defense. With space increasingly becoming what military officials describe as a contested domain rather than a sanctuary, the need for defensive capabilities has grown more urgent. ULA is already preparing for its first Space Force mission with the Vulcan Centaur, scheduled for late 2024 or early 2025. If successful, this defensive upgrade could provide ULA with a unique capability in the competitive launch industry while addressing crucial space security needs. And that brings another episode to a close. Thanks for joining us on Astronomy Daily. I'm Anna, and you can catch all our back episodes and latest space news at astronomydaily.io. Don't forget to sign up for our free newsletter and join us on social media. Search for Astro Daily Pod on Facebook, X, YouTube, Tumblr, and TikTok. Until next time, keep looking up and wondering about what's out there. There's a lot to absorb.